Last month, an AI from a Tokyo-based startup called Sakana AI entered a live programming competition and placed 21st out of over 1,000 human participants. It outperformed 979 elite coders from Japan's toughest competitive programming scene. The singularity is here. Your job is obsolete. Time to go touch grass. Or is it? Because this story is not what it seems. This is closed source, and let's talk about AI. Now, when an AI demolishes a field of human experts, we usually assume it's some next-level AGI. But the system that competed here was not Sakana AI's much-hyped AI scientist project. You know, the one that got publicly roasted by academics for producing papers like a rushed undergraduate with a 42% failure rate in its own experiments. No, this was a different beast entirely, a specialized system called the ALE agent. And its success wasn't about superior reasoning, it was about picking the perfect fight. The agent didn't compete in a standard contest where you find one provably correct answer. That's the turf of systems like DeepMind's AlphaCode. Instead, it entered an AtCoder Heuristic Contest. These are optimization problems with no known perfect solution, like optimizing a factory schedule or a delivery route. The goal isn't to be right, it's to get the highest score possible within a 4-hour time limit. It's not a test of genius invention, it's a game of continuous, brutal iteration, a perfect environment for an AI that never gets tired and doesn't need bathroom breaks. So how did it pull it off? The agent's core is a hybrid strategy, a centaur approach combining human expertise with machine-scale execution. At its heart is Google's Gemini 2.5 Pro, but it's not acting as a brilliant solver. It's a code monkey on steroids, embedded in a loop where it generates code, gets a score, and is told how to improve it. But here's the asymmetric advantage that made victory possible, the iteration gap. An elite human coder working at peak efficiency might submit about 12 refined solutions in the 4-hour contest. The ALE agent submitted around 100, that's nearly a 10x advantage in throughput. And those 100 submissions were the result of thousands of internal trial and error cycles. But it's not just brute force slop. The agent's search is guided by a 3-pronged strategy. 1. Best first search. It relentlessly focuses on the most promising solutions based on score. 2. Beam search. It doesn't just try one idea at a time. It runs a beam of 30 different solution paths in parallel, preventing it from getting stuck on a bad idea. 3. Taboo search. It keeps a list of recently tried solutions to avoid wasting time going in circles. This isn't just a faster coder, it's a parallel army of coders guided by classic human-devised heuristics, like simulated annealing. And here's where it gets really crazy. The agent went beyond just applying the strategies it was fed, it demonstrated genuine algorithmic discovery. During the contest, it identified a bottleneck in its score calculation and independently devised a Poisson approximation to speed it up, a creative leap from probability theory that was crucial for its success. That single adaptation boosted its rank from a projected 82nd place to its final 21st place finish. So, the ALE agent's success proves that the future of engineering isn't about humans versus AI, but a powerful human-AI collaboration. It's a shift from being the person who writes every line of code to being the architect who defines the problem, designs the scoring function, and provides the strategic guidance. Your job isn't to compete with the machine's ability to iterate at scale. It's to be the human who tells the machine which mountain to climb.